artificial intelligence. It's completely reshaping our world, and it's doing it at a pace that's kind of hard to wrap your head around. It promises this amazing future of efficiency and discovery. But lurking behind this whole digital revolution is a massive and growing physical appetite for one thing: energy. So, are we looking at the key to a sustainable future, or is AI actually a new threat to our power grids? Let's get into it. If you really want to understand the sheer scale of what's going on, just follow the money. That number right there, that's $12 trillion. That's how much the market value of AI-related companies shot up in just 2 years after ChatGPT landed. This isn't just hype, folks. This is one of the biggest economic shifts we've ever seen. It's a genuine 21st century gold rush. And this slide really paints a picture of that investor frenzy. By 2024, if you were an AI startup, you were worth 5 times more than a regular startup at the same stage. The message from the market couldn't be clearer. AI's the future, and absolutely no one wants to get left behind. So, here's the plan. First, we'll dive into this gold rush. Then, we'll uncover that hidden energy build that comes with it. After that, we're going to flip the script and see how AI can actually be an efficiency expert and even help invent a cleaner future. And finally, we'll wrestle with the ultimate power question. All right, first up, the gold rush. We're talking about a technology that is weaving itself into the fabric of our society faster than almost anything that's come before it. Okay, so it helps to quickly break down the 2 main flavors of AI we're discussing. You've got predictive AI, which is all about forecasting things, from weather patterns to figuring out protein structures for new medicines. And then you have generative AI. This is the one you've probably played with. It's the magic behind tools like ChatGPT that can write an essay or create a wild image from just a few words. And the way these tools have caught on, it's just staggering. We're not talking years, we're talking months. 40% of households in the US and the UK were already using this stuff within 2 years of it hitting the mainstream. This isn't some niche tech for developers anymore. It's already in our homes and at our jobs. But all this incredible growth comes with a catch. A big one. And that brings us to the hidden energy bill. This amazing digital expansion has a very real, very physical cost that we're only just starting to wrap our heads around. You see, the energy gets used all along the AI supply chain, which you can really break down into 3 big steps. First, you have to actually make the incredibly complex chips. Then you use those chips in massive data centers to train the AI models. And finally, there's inference. And that's every single time you ask an AI a question or have it generate an image. Each step is thirsty for power. Now get this, that very first step, making the chips, it's heavily concentrated in one part of the world. Over 70% of the most advanced chips come from East Asia. And to put the energy impact into perspective, one single company, TSMC, used almost 10% of Chinese Taipei's entire electricity supply in 2023. Just wow. Okay, so then you get to the training phase. Think about it like this. A single high-end AI chip can draw as much power as your kitchen toaster. Now, imagine the thousands of those chips used to train a model like GPT-4. We're talking about the same power draw as about 150 high-power EV charging stations, all running full blast at the same time. And what does all that add up to? Well, the estimate just for training the big AI models we know about so far is around 1,700 gigawatt hours of electricity. And you have to remember, that's just a snapshot in time. This field is growing exponentially. That number is only going up. So you have to ask the question, right? Are we just building a new, incredibly power-hungry industry at the worst possible time for our climate goals? It sure can feel that way. But that's only half the story. And this brings us to the other side of the paradox. What if AI could be the world's greatest efficiency expert? What if, just maybe, it could help us save way more energy than it consumes? Let's start right at the source of the problem, the data centers themselves. The industry is already working hard on this, attacking it from 2 angles: smarter hardware, like new low-power processors, and much smarter software, like building smaller, more specialized AI models that don't need as much juice. But the real game changer is what AI can do outside of the tech world. Think about heavy industries, steel, chemicals, cement. These sectors are massive energy hogs. AI can dive into their complex processes and find ways to slash energy waste. This is one of the biggest opportunities we have for decarbonization. And hey, This isn't just theory, it's happening right now. AI is already cutting energy use in smart buildings by more than 20%. It's helping airplanes fly smarter routes to reduce their climate impact. It's using predictive maintenance to make power plants more reliable, saving billions of dollars. The applications are literally everywhere. So, making today's systems better is one thing. That's huge. But what about inventing the systems of tomorrow? This is where AI's potential gets truly transformative. You have to understand, historically, energy innovation is slow, painfully slow. It took things like solar panels and lithium-ion batteries decades to go from a lab experiment to being a mass market product. That's a timeline we simply don't have anymore in the face of climate change. We need to compress decades of progress into years. So how can AI help with that? By doing what it does best. AI is an absolute master at finding tiny patterns in massive, complex datasets, like all the possible combinations of atoms for a new material. It can do it far faster than any team of human scientists ever could. It connects dots that we didn't even know existed. This leads to a revolutionary concept, the self-driving lab. Picture this. An AI comes up with an idea for a new material for a better battery. A robotic system automatically creates it and tests it. The AI instantly analyzes the results and refines its next idea. It's a discovery loop that can run 24/7, getting smarter with every cycle. And if you think that sounds like science fiction, well, it's not. This is a real-world example from a national lab. Their A-Lab system basically digested over 24,000 scientific papers and then, on its own, successfully discovered and created 41 brand new materials. That's a glimpse into a future of machine-speed scientific discovery. Which brings us all the way back to where we started, to the ultimate power question. We've got these two incredibly powerful, opposing forces of AI, the problem and the solution. How in the world do we weigh them against each other? This chart right here really captures the entire paradox in a single image. On one side, you have AI's massive energy demand, straining our grids and consuming resources. But on the other side, you have its incredible potential as a solution, a tool to drive efficiency, optimize our world, and accelerate the invention of clean technologies. So in the end, we're left in a race, a high-stakes race between AI's growing consumption and its problem-solving power. The outcome isn't written in stone. It's going to depend entirely on the choices we make as policymakers, engineers, and citizens about how we decide to build and use this incredible technology. The question is, which side of this paradox will win out?